Hello everyone, welcome back to another video. Today I'll be going over the Pythagorean Theorem. Now the Pythagorean Theorem, it's probably one of the most simple concepts you're going to learn in grade 9. Now you do need to know a little bit about chapter 3 and 4 for this, but other than that, not too difficult. So, what's the formula for the Pythagorean Theorem? Well, it's a squared plus b squared equals c squared. It can also be written this way. Doesn't really matter. Okay? So, when do you use the Pythagorean Theorem? Sorry if I'm not saying that right. It's a bit of a tongue twister for me. But anyways, you can only use this when you're dealing with a right angle triangle. So, can only use with right angle okay? You can only use it for a right angle triangle. It will not work for a triangle that's not right angle, alright? So, let's draw a triangle. And pretend it's right. It's not going to be drawn to scale, but assume it's right, okay? You need to know something called the hypotenuse. So, I don't know how to spell it. Give me a second. The hypotenuse. What is the hypotenuse? The hypotenuse in a right angle triangle is always the longest side, okay? And if you don't know what the longest side is always the side that's directly across from the right angle. So this is directly across. This side is the hypotenuse, and it's directly across from the right angle. All right? So let's say we have a triangle like this. And this is our right angle. This is the hypotenuse. I'm just going to say h for hypotenuse because it's directly across from this right angle, therefore it's the longest side, okay? And the longest side, the hypotenuse, the letter that always represents that, it'll never change, is C. The letter C is what represents the hypotenuse, okay? So, this C right here. So, what's the point of the Pythagorean Theorem? The point is, if you have a right triangle, and you know two of the sides, you can use this formula to find the third side. Okay? So, let's erase this triangle down here. Let's say this is 7 and this is 8. Okay? Now, once we've labeled C as the hypotenuse, A and B don't matter. They're just the other two sides. This can be A, this can be B, or this can be B, this can be A. I'm just going to label it AB, but it does not matter which one's A and B. It just matters which one's C. You can't put B or A in the hypotenuse. C has to be for the hypotenuse, okay? So, it doesn't matter which formula, I'll use the top one, but you can also use the bottom one. It's just written in a different order. I'll just write it out again. A squared plus b squared equals c squared. So what's A? It's 8. So 8 squared plus b squared, 7, equals c squared. Okay? So what's 8 to the power of 2? I should have picked smaller numbers. 64. And 7 to the power of 2 is 49. Equals c squared. So what's 64 plus 49? 60 plus 40 is 100. 4 plus 9 is 13. So it's 113. Okay, so we're not done yet because this is not the side length of C. This is C squared. So if we want to find the side length of C, if C is being squared right now, what we want to do, we want to get rid of this square root. So how do we do that? We take the square root of C squared to get rid of the square root. But if we're square rooting something on the right side, we do the same thing to the left side. Okay? So that's equal to C now, we got rid of the squared, equals, this is going to be some weird decimal, so I'm going to keep it in this form. But let's say this for 25 and you were able to get a perfect square root, you'd have to write that. Okay? So let's say this for 25. Let's say, just assume, this is the right answer for this question, but just assume this for 25 for a second. Okay, we're square rooting this, we're square rooting this. C is equal to the square root of 25 is 5. So if it's a perfect square root, write it out. If it isn't a perfect square root, check with your teacher and ask them if they want it in this form where it's still a square root, or if they want it in a decimal, as a decimal, all right? So ask your teacher that if you don't know. But yeah, pretty simple. Now, I'm just going to show you one more example. What the heck? Okay, it's okay. So that's how you use the Pythagorean theorem. Now, you can also use it to solve for a side other than C. Okay? So for this next example, I'll use smaller values. Let's say we know what the hypotenuse is. Let's say it's, trying to think of a good number. The hypotenuse has to be okay, let's say it's 10. And let's say B is 5. Solve for side A. Well, if this is the formula, if I'm solving for side A, I want to isolate that side. So to isolate A, I want to get rid of this B. So I can subtract B from this side. Therefore, I have to subtract B from this side. So therefore, this is A squared equals C squared minus B squared. And now that I've done that, plug in the numbers, solve for A. Pretty simple. So A squared equals 10 minus 5 squared. A squared equals 100 minus 25, 75. Again, I didn't pick good numbers, but A, you have to take the square root of A. We have to do the same on this side. A is equal to, I'll see if there's a square root for 75. There isn't a square root for 75. So you can keep it like this, or you can put it into a decimal. Ask your teacher. A is the square root of 75, which I believe is like 8 point something, 8.8 something, and a bunch of numbers. But yeah. So yeah, pretty simple.